Hi guys, you are watching channel Mr. Electron, and today I'm planning on salvaging components from an old CPU that has been lying around for 10 to 15 years. It's really old and is no longer in use, and I'm especially interested in its power supply, but let's see what else can I find there. 6,700. More. 8,700 RPM. Very high speed. More. We are reaching 11,000 RPM. Let's go more. 12,700. 13,500 RPM. Let's go even more. 14,500. More. Let's go a little higher by increasing the voltage because the speed is full now. 16,000. More. So 16,000 is the max I'm doing here. Well, it was actually AAA battery type, but I converted it into a rechargeable one. You see the provision for charging and lithium-ion batteries and the on-off circuit. So here we have it, a floppy drive 2003. Now I would really like to open up a floppy drive and look what is inside because I've never done that before. Although I've done the same thing with the CD and DVD drives many times. So that's how your floppy drive looks from inside. So today I'm going to open it further and look what else is inside that I can salvage. Now guys, if you look closely, you will see this GND term, which is for ground and is soldered to this white wire. So this is going to be our negative, overall negative. And as for the positive, it is 5V, positive 5 volts. And let's give you a closer look. So here, as you can see, this is plus 5 volts, which is soldered to this yellow one. So let's try white and yellow and see if it works. So guys, that's my 5-volt supply that I'm going to use to test my BLDC motor from the floppy drive, and links for the components used in this project have been provided in the description. You can check it out and buy it from there. So seems like that it is not working. Therefore, I'm planning on using an external driver, BLDC driver. This piece is for hall sensor. Now guys, this what you see is my dead soldering iron, and I'm going to reuse its bit. because as you can see that the space between the armature poles is very small and I have to desolder the thin wires to take out the armature. Now guys, this one is my working soldering iron. So here I'm going to replace the bit with the one I just made. Now guys, to measure the RPM at which the disc is running, here I've placed this black tape, and this is the open area that is going to reflect the laser back to the tachometer. So guys, here I'm running the motor at 17 volts and here I have around 6000 RPM. (19.1 volts), we have 14,000 RPM. Now I'm going to test this motherboard cooling fan 12 volts with my variable power supply, link for which will be provided in the description. You can check it out and buy it from there. And as you can see that it is working quite nice, which is good. Finally comes our main power supply, for which I'm actually making this video. So let's open it and see how it looks from inside. Now guys, the serial number for this power supply has been provided, but even if we consider the lowest one, we are going to get a max of 12 volts and 6 amperes and 10 amps at 5 volts, which is quite good. Oh, it's really dusty and I expected nothing less. So after cleaning it up, let's check if it is working or not. So the first step is to take off the wire bunch from its slot. After that being done, you have to cut the wires in such a way that you remove only the end pin outs. Yeah, you have to remove the zip ties as well. Now for understanding this wiring, we will have to open up these screws, this one and all, to look what is below the circuit. I mean how these wires have been connected to each other. That can be seen how they have been soldered on the second layer of this PCB. So let's remove the screws. It is really important for full utilization of your power supply. So let's take it off. So guys, I have understood the wiring completely except for these two wires. I don't know what these two are used for. The rest, here it is. I have to mark it although. Let's place it back in and then do it. So guys, I've placed it all back and I'm also done with the labeling. This green wire is the start wire. The red one is your plus 5 volts. Blue is minus 12 volts. White is minus 5 volts. Yellow is plus 12 volts. Orange is plus 3.3 volts. And finally your black one is your overall ground. I still don't know what is the use of this wire and the gray one, so I'm going to leave these two behind and I'm going to utilize the rest of them. So guys, it's time to power it up. You're also going to need this connector cable. It fits in here, and plug it in and turn it on. Oops, it didn't start. I have to connect the start wire, and when it starts, the BLDC fan that you see, the exhaust fan, it is going to start running. So you have to take the green wire, you see I've already stripped it, and one of the black wires, and then it starts. So it's running. So what you have to do is connect it permanently. I'm going to turn it off and take one of the black wires out of so many present. Twist it like this. Now let's test the power supply. Now guys, I have this car headlamp bulb, 12 volts, 60 watts. So let's connect this one and see how it works. Yellow wire is plus 12 volts and ground is common. So yeah, you see. So let's do the multimeter check for the exact output volts, and here we have 12.8 volts DC. Now we have our red wire which is positive 5 volts, and here we have 5 volts exact. Now comes the orange wire, and here we have 3.4 volts. Now comes the important part, the negative 24 volts. Let's test this one. Negative means black is going to be connected over here and positive over here, and we have our 24 volts output. Oh, that is nice. Now I just figured out one more thing. Connect one wire to the negative 5, which is white wire, and the positive to positive 12. And here we have our 18 volts, 17.85. Now let's connect it to the red one, 10.18. Blue, it is minus 6.88. So if we reverse the polarity, we will have plus 6.88. Yeah. And if I connect this red one to the orange one, we have 8.48 volts. Now guys, let's start with some practical applications. Application 1. Charging of AA and AAA battery cells. Now guys, if I choose two different wires, one plus 3.3 and the other one as plus 5 volts, the combination is going to give me 1.6 volts. And with this, I can charge my 1.5 volts AA and AAA batteries. So here the cells are connected. Red is connected to positive 5 and green is connected to orange. Now to know for sure that it is actually charging my cells, what I'm going to do is connect the meter pins, one to negative and other to the positive. and here we have 1.261. Now if it is going to increase, it will indicate that yes, it is charging. So I will have to wait. And here we have 1.262. Second application, charging your 3.7 volts battery, for which you are going to need the 6 amperes diode. Now this white wire indicates -5 and this black is ground. If we check the voltage, and the output, as you can see, is only 4.9 volts. So what I'm going to do is take this diode, and because black is positive this time, so this diode is going to create a 0.7 volts drop, making it only 4.2, which is needed for our lithium ion battery for full charging. So here I'm going to use two cables, black and white. Black will represent negative, of course, so -5 to jumper cables, link for which is in the description, and the white is for negative of the diode. So we have white one overall positive and black overall negative, and the battery this side is positive. You see there is a little indication of the positive. Yeah, so our cells should have started charging. Let's check it. So here I've connected the meter pinouts, and it's showing here an increasing voltage. It has reached 4 volts and increasing. Now the third application is the use of the 5 volts wire, which is the USB. So we all know what this is going to be used for, charging your cell phones or headphones. So I'm not going to get in details. You can also charge your 6 volts lead acid batteries by using a combination of white and blue, and the output is 6.74. And here is our 9 volts combination DC output at the yellow and orange, which can be used for charging our 9 volts batteries. Now comes the 12 volts. So this is plus 12 volts and this is ground. Now this one is my 80 watts night eye car headlamp bulb. See, it is so bright. Oh, very bright. And guys, please note that for best performance output from this power supply, make sure that you solder the similar colored wires, like all the yellow wires together, all the red and all the black together. Because my model, as you can see here, is this dot indicating 480x. So it is 5 volts, 20 amps output, 12 volts, 10 amps, and max up to 300 watts. So obviously I will need to solder all of them together to get the highest possible current output. Now guys, this motor is 22 amperes motor, 12 volts, 22 amps. Whoa! Whoa! Yeah, it is like pulling my hand upwards very... extremely high thrust. That's a really great salvage. So guys, now comes the testing part for our 24 volts motor. So let's connect it and see. And the wires we are going to choose here is the yellow one, which is positive 12, and the blue one, which is negative 12. So together the difference is going to be 24 volts. Here you see, it is working quite nice. So guys, this is a 36 volts 15 amperes motor, again from an e-bike. I've already connected one wire to the positive 12 volts, and now comes the negative 12 volts, which means that I'm going to run it at 24 volts instead of its rated 36 volts. So let's connect it. Whoa! A very high inertia. And now comes the final part. Can we charge a 12 volts battery? And the answer to that is yes, of course. So here I have placed a multimeter. Take one cable of the multimeter and one negative 12 volts wire. You see, negative 12 volts. Okay, and hold it like this, so it's held there. Now take the other one, which is positive, and connect it to the plus 3.3, and here we have our 15 volts DC. So all we have to do is reduce it a little bit. So take the diode and focus on the gray side and the terminal of that, which will be connected to the negative 12 wire. After that comes your battery. So the negative wire will be connected to the negative terminal of the battery. Now here I've also connected a multimeter, I mean one of its terminals, which is black, to the negative, and the diode is just behind it, if you can see here. Now I'm going to connect the other terminal, and the multimeter is showing 11.94 volts, which means it is completely discharged. So let's connect it, and when I'm going to connect this wire, like I have connected this white wire to the orange one, which is the 3.3, to this terminal of the battery, positive terminal, and if it shows change in voltage, means it is charging. And here, as you can see, that the voltage is increasing rapidly, so I will have to leave it connected for a longer duration. And yeah, it is charging the battery quite good.